Okay, so good evening, good afternoon, good morning. Because since we are spread along so many different time zones, welcome to another session of our Digital Futures talks. And today's session we bring together some of some of the questions I've personally resonated through my master's learning experience at IAC and teaching experience as an assistant professor at Balban State School of Architecture. So before we dive into the whole talk completely, we just wanted to let you know about the other sessions that we would be conducting after this. Sorry, 1 second. Yeah. So we are continuing our regional talks, and we have our Arabic regional talk scheduled next for today at 3 p.m. EST. And tomorrow on Sunday, with in collaboration with Florida Institute FIU, we have another doctoral consortium session happening, and they would be talking about Andy Clark. On 2nd April, we have another tutorial session happening, and the instructor would be Dhruval Shah. We would be exploring through the urban cartography through open source data. If anybody would like to register, the link will be shared on the chat and it's also there on the screen. So feel free to register for this tutorial session. And for any other videos that we are posting, since our weekly talks are there on our YouTube channel, and feel free to look into it and dive through the different topics that we are discussing. And ultimately, if anybody and everybody who's interested to become a team member for our Digital Futures team, you're welcome. We are about to begin our summer workshop, so we would really love to have some volunteers who would take part with us. And coming back to our main event for the day. So today's session is about clay printing in architecture, and this session we are attempting to bring together experts from different regions discussing their advancements in architecture through the medium of clay printing at various scales and contexts. Alexander Dubois, he would be representing IAC instead of Eduoard Cabay today, and they will be talking about their ongoing research on earth-based 3D printing through their 3DPA program at IAC. Lidia Ratoi will be presenting her research on ceramic printing and materiality. Negar Kalantar and Mehdi Farahbakhsh would be presenting design parameters, the process and the material parameters for use during the robotic deposition of clay-based materials and architectural form finding on meso and macro scales. And lastly, Erno Langenberg would discuss his explorations into the digital fabrication of sustainable architecture and ceramics. So to begin, our first speaker is Erno Langenberg. I hope I'm spelling your name correctly. Please correct me if I'm wrong. Just to introduce him before he begins his presentation, he's an architect, researcher, and educator based in Rotterdam, founder of L Studio, and currently working as a researcher at the Digital Production Research Group from the Amsterdam University of Applied Science, where his research is focused on the use of digital fabrication to turn urban waste streams into circular products, thus contributing to improving the sustainability of cities. His interest lies in the interplay between computational design and fabrication, generating sustainable design solutions while exploring new formal language. And Erno, now the floor is yours and you may begin.
Yeah, hello everyone. Good day, morning or evening. Here it's a very sunny afternoon in Rotterdam. So I will start sharing my screen right now. Let's see if it works out. Is it visible?
Okay. Yes.
All right then, let's start. Well, first, thank you for organizing this event and inviting me to talk. I'm actually really looking forward to see all the other speakers. So let's start by myself first. You already introduced me. I will talk a little bit about it to give a bit of context to the research I'm going to show. because I was having my own office for quite a while, where I did a great variety of works, from small designs to big landscape. And one of them was 3D printing ceramics, which we come back to. But at the moment, I'm working at a robot lab in Amsterdam. It's a robotic fabrication education facility where we try to combine practice, research, and education, which is super interesting. However, we're not working at the moment with ceramics. We're working mainly with wood and 3D printing with plastics. So the work I'm showing here will be a little bit older, but hopefully we will get back to working in ceramics pretty soon. It all kind of started where I was with some friends working on a project in Zambia. It was a sustainable hospice building, and the idea was to make it from a local source material, which we visited a location and we figured out that there was, of course, not that much material available. And for the roof, we were depending on a kind of limited amount of steel, which was locally fabricated, which was only a 40 by 40 L profile. So what was quite interesting, we worked with an engineering company who reverse engineered with this only available steel material, a kind of complicated roof, which was fairly easy to mount, but I said just from the local available material. And in this sense, parametric design helped quite a lot. So it was, software was complicated, but the material was very simple. The project is still being built. It's a kind of slow process, but being on the side, as I thought, like, yeah, there's so much other material as well, which is not used. So that's where my interest started in 3D printing with local material like clay or earth. So this kind of combined my interest in digital programming and fabrication and the material of the earth, with the idea to make a very sustainable way of building. So I started my research in 3D printing, first making this little graph, finding out that there was already a lot of things done. But my main interest was to have local material in order to avoid this global movement of materials all over the place, which now is actually quite interestingly more urgent than ever because of the global situation. So, and of course, with the idea to go to a more circular building practice where knowledge is gone through the world, but not the material. So my choice of material was clay. So the research started out, what can we do with clay, which is local, available more or less around the world, and also applied in architecture quite often, like you have, of course, roof tiles, bricks, and all this kind of elements. So what could a digital fabrication add to this process, which is basically the kind of extrusion of clay paste, if you put it simply, which led me back to the kind of old way of making pots, which is coiling. It's quite known in pottery, and normally this is done by hand, and also the clay is smoothened a lot of times also by hand in order to make the print a bit stronger. However, this, I thought, for architectural application was a bit limited because you're stuck to a kind of a vessel shape. And I wanted to explore what are the possibilities of opening up this structure in order to let, for example, air in or liquid or light through. So my initial thought was to have two ways. You could either make holes or rotate the print. The research entails, of course, I think, which is important to have experience or experiment on these three fields, and ideally they come together in the middle. So I set out for a few years of experimentation with all different materials. We hacked various different kind of 3D printers, CNC routers, and the sorts, and of course looked into the software, which was at that time not so much available. By now there is some more booklets and tutorials how to print clay, which makes life much easier. Still, I think it's quite a big step for students to step into this. So the first experiments were these objects, which was basically turning the print around and defining yourself the printing path. And by overlapping the clay, which allows, because it's a kind of a smooth material, you can make a kind of lattice-like structures. And actually the crossing of paths is quite a good thing to do, because it makes the clay only stronger. From this, the next project stems, where this is already a bit more kind of architectural application, where these bricks could be stacked without using glue. And in this way, you could envision a kind of a small pavilion being made, where the bricks are adjusted to the local needs, like ventilation or air or sunlight, if you will. By just changing the script, all of these bricks are identical in terms of code. Well, this was one a kind of visualization, and eventually, if you would have the time, this could be a kind of a pavilion you could be making with this technique. We'll come back to this time issue in a bit at the end. So the next attempt I did was to open up the vessels, if you will, in another direction. And this you can do, of course, by changing the geometry. You can use arches or kind of triangular spaces. But I thought to do it in another way, in using a different material. Like in plastic printing, you use a kind of a support material, but in clay, it's not often used. And it could be an ideal solution, because clay has to be fired in a kiln, and at that temperature, everything else but the clay will disappear for sure. So you could, if you are able to print with two different materials, the second material will disappear or disintegrate. I was having the luxury to try this out all at the European Ceramic Workspace in the south of Holland, which is a great workplaces and different kind of kilns where you can try out this. So we tried all different inorganic and organic materials. Some are more successful than others. Some organic materials which you think will disappear turn out to be glazings and so on. It's quite fascinating. But it requires a lot of attention and a lot of further research. We managed a few materials which were workable, like the one on the left is a kind of mixture between bentonne and other kind of ingredients, which turned into powder, which was a kind of successful start of it all. The right is a more organic material, which worked, but it was impossible to control in a sensible manner. Side effect of this was while I was playing with the dual extruder, also find out that there's different ways of extruding, which I thought was interesting to see, because it changes the aesthetic of the normally horizontal like layers into a more aesthetic appearance, which is quite different from what you see normally. And I think it's interesting to play with. A next residency I did was in Scotland at Cove Park. It's an amazing place next to the sea, where you have your own studio. I installed my two printers and started experimenting a bit further on different ways of opening up the structures. And one of them was also a bit more the rotated print, where I incorporated the locally found beach glass, which melts at the same temperature as the ceramic, so you could integrate it quite well. But the next one was already, the previous was a quite simple trajectory for the printing, but this is a more complicated one, which combines alternating layers in different directions with the idea to open up the structure. And as a result, of course, we cannot ignore gravity, so the clay will drop down because it's very bad at bridging. But luckily, it's going down in a controlled manner. So you could tell in advance how far it would go down. So in that way, you can play with the bad qualities of the clay in such a way that it becomes interesting for you. I printed a lot of these objects, and eventually, all being the same, they could be stacked into this kind of ornamental column, which has a kind of organic feel to it, although it's a completely scripted object, and it's all just basically ones and zeros. I think it's a quite fascinating idea. Another experiment was a bit more free and constrained at the same time. It's printing on a mold, which is also a technique used in ceramics. And it gives the freedom of printing in real 3 dimensions, while at the same time being free at the depositing of the clay itself. And you can imagine that you can have a very intricate patterns and crazy shapes, but still following the same curve, which I think could be quite useful for architectural applications. These might be too small, but I think if you scale it up, it could be interesting. The last project I'm showing here is a non-finished project, but it's more recent, and it's a beginning of something more architectural. It's a commission I had for the foundation Fabrication. They're in the middle of Holland, based next to a river, and they asked artists and designers to work with the local clay they found next to their location. And a lot of different projects are being done. And they asked me to come up with a little facade cladding for the building they have here on the top. And it was an ornamental facade tiling. We started out thinking about the maximum kind of tiles which we could make, because the idea was to have it all locally produced. So we would bring in small printers, and they had a small kiln, which was basically the bottleneck of the whole process, because the kiln size was limited. So we couldn't make the tiles too big. When you lay them out on this building, which was an old building and not straight at all, you of course have a lot of corrections at the edges. So that's I thought the idea, if you're gonna have a lot of different ones and the printer doesn't mind, you might as well have them all different. So therefore I made a design with all completely different tiles, kind of representing the flow of the river, and this could be interesting to be done. So we all were happy, and we started thinking about how to make this. And of course, there's a lot more to it than just printing these tiles. We had to dig, prepare the clay, printing and firing the kiln, glazing and firing again. And then, of course, in the end, mounting the tiles. And adding dates to it, we came to the conclusion that it's a quite lengthy process, especially the printing would take very long. And eventually there was this idea to make a little print farm, and we could reduce the printing time enough so it would be a feasible project within the time frame we had, the location, all by local means. And so we didn't have to travel around with the clay or the prints or for that matter. So it was ideal. But it made me think about how to scale this up, because this is in fact only a small facade. It's really not that big of a project. Oh yeah, well, small note is that the project will be finished, but in a different building. But I will continue. Because if you think about the house, which requires around 8,000 bricks, could you do this in a sensible manner in the way we make this little local project? And I think it becomes a bit more difficult because of the amount of time and the amount of hours, and still these printers don't run unattended. So look, most likely, I'm going to get to the end. This would be more feasible in a kind of factory-like setting like this big British factory, where there's already robots available. So it could be interesting. So my question was also, where does the added value of 3D printing in ceramics, which is different than the later project, which is 3D printing with not burnt clay, where could this be? Is it in a factory? Is it really local? And how big would it be to make sense at all on an architectural scale? Because in the end, we talk a bit more like in a product-like object. And this is just a final last slide, because if we have time at the end, I thought it could be also interesting to look into other things than just the technological side of the whole idea of making bricks. This is a wonderful movie documentary in comparison, where they show different ways of making bricks, at the same time highlighting the social aspect of building as well. And you can see that it's really different in the scaling of the small scale building and brick making, and the large scale, more automated processes, which are far more a way different approach to it, I would say, in the use of the making and the building process in a social way. So I think I'll close it by this. I want to, well, thank you for your attention. And I don't know if there's room for questions right now, or do we do questions at the end?
We will do it at the end once we have see everyone's presentations. So thank you. But like, yeah, I really, your session was really interesting, and like I really like how you closed it with the social cultural aspect. Is really important with this material, and I really like the way you actually closed it. So moving on forward, I think next is Lidia. So Lidia, hi. So before you begin, I'll just give you a small introduction. So Lidia Ratoi is a graduate from IAC Barcelona with the Open Thesis Fabrication program, and has previously completed her master's studies in architecture at UIM Bucharest. She's currently coordinating year 2 undergraduate degree in Hong Kong University Department of Architecture, and working on projects investigating sustainability in the realm of robotic fabrication. Her current research project, Impossible Bricks, mediates the use of bioplastic materials in pair with additive manufacturing, focusing on ethical use of digital technology and sustainable construction building processes. She has previously taught at the Royal Danish Academy of Fine Arts. She is the 2021 recipient of the Early Career Teaching Award in Hong Kong University. So Lydia, the floor is yours to begin.
Hi, everyone. First of all, thank you for the invite. And I just want to start by saying that's probably the most nerve-wracking lecture I've ever done, because Alex was my professor in IAC. So I really hope I don't disappoint him. Maybe I can share my screen. Can you see my screen? Sorry,
Yes.
Sorry, let me go to the first slide. Okay, so I'd like to start the talk today. I want to also frame it a little bit around what I'm trying to achieve, what is my work methodology, and what I'm kind of advocating for. So I want to start by stating that I think design is a personal responsibility, and I'm advocating for a design methodology that is as rigorous as the process of patenting an invention. So investigating from the existing reality to every other possible scenario. And I want to stress the importance of architects taking personal responsibility, because architecture, through its very nature of creating artificial space in the natural world, It has historically acted as an element which kind of disturbs the environment. So I consider that given the current state of the world, it's up to each designer to treat the building environment as a personal responsibility and operate as such. And on the question of ethics, as the designer operating with digital technology, I kind of feel an additional pressure to mediate this in a cautious way. So my work investigates the potential of design on various scale, and I mostly use free tools, digital fabrication techniques like robotic arms and 3D printers, reinterpreting ancestral ways of making, and material development, all regarded as site-specific solutions which adapt to local conditions. And the impact I'm trying to measure is how technology is changing, how are we influencing the communities for which we design for, and how is nature growing and thriving instead of adapting to what we're doing to it. So as an introduction, I'd like to very briefly present my first project dealing with the issue of robotic fabrication. Terra Performa down with Nyack, Barcelona. My thesis advisor was Alex and Eduoard Cabay. And I really want to thank you them for giving me a very healthy introduction to the world of robotic fabrication. And I use the word healthy because a lot of time we use students, we teach students how to use tools, but not how to question the ethics, the implications, or the potential of these tools. So I think I was super lucky because the brief for this project consisting in constructing a 3D printed clay house with a self-regulating environment. So we were taught how to question and how to quantify our designs. So as opposed to what I would have imagined about robotics, because that was my very first experience with robot fabrication, there was a lot of research on historical background, taking inspiration from vernacular architecture, such as the wind catchers of Iran, the clay towers of Yemen, which allow for self-cooling on the inside of the building. And each brick had its own unique logic regarding solar radiation and wind patterns, but the overall facade worked cohesively. And all aspects of the design were calibrated for the site in Valdaura. And I think around this time, I really started to question the projects that I was seeing done worldwide, and most importantly, these kind of trends in computational design. And one trend that I really took a stand kind of against was that of mass customization, which implies that the same machine, the same digital file can create an entire catalog of unique elements, though they're all distinguishable from the same mother entity. And I took the liberty to go against this trend because I consider it doesn't really respect the intelligence of a robotic arm. They're really versatile tools. They can be used for different building techniques, subtractive, additive. So one machine can substitute many others. And this leads to a much lower carbon footprint of the entire process. And if you pair it with locally sourced material and the use of local builders, you can really aid in creating material and tool passports, which allow us as designers to track the entire process and quantify its potential for a participatory and a non-exploitative building methodology. So other influences that I started to look into were, of course, from designers such as Neri Oxman, who's doing cutting edge research in biomaterials and robotic fabrication and soft robotics, and Gilles Retzin, the pioneer of discrete architecture. And I remember at the time I was actually preparing to interview him for Cloth magazine. And so I got to spend a lot of time researching his work, reading about it. And I got really interested in the world of object-oriented programming and object-oriented ontology. And I think possibly the most inspiring element was Mark Foster Gage's arrow diagram. So it protests the treatment of architecture simply as a diagrammatic means that needs to be simplified until the point at which can be built the easiest. And this has been a big influence on my work because when working with biomaterials, the behavior of the material can be revealed through an extensive trial and error procedure in pair with machining protocol. But you can only really discover answers because the methodology is quite new, so you cannot be given answers. And this brings us to reformative coral habitats. This is the project that I was really lucky to be a part of in Hong Kong University, my first project when I joined Hong Kong. They actually started the project a little bit before my arrivals, but I arrived exactly at the fun part, the design and the testing phase. And it's a project in which all 50 units are identical for extremely specific requirements. So the project was a collaboration between the architecture team, the architecture department in Hong Kong University and the marine biology department in Hong Kong University. So it brought together very different sets of expertise. And it was tailored for the unique conditions of Hong Kong. So Hong Kong is a city with an extraordinary richness of nature, but it's also one of the most dense built environments in the world and has really high pollution levels. And other than pollution, part of the reason that there was such a big need for coral restoration was that in 2018, Typhoon Mangkhut damaged about 80% of Hong Kong corals and left behind only coral fragments. And something just interesting to note is that underwater flora and fauna are really versatile. They're like a human society, so they change for different periods of time. And currently there are 3 main species of corals in Hong Kong waters, Platygyra, Acropora, and Pavona. These are the corals that we designed for. And Platygyra is the one that is dominant right now. And these were the 3 amazing sites and 3 different islands in Hong Kong that we got to dive and go to. And the project, as I said, was designed specifically for Hong Kong conditions. And the 4 main conditions that we took into consideration was, it's one of the most polluted waters in the world. And that means that there's an urbanized reef, the same we can find in Singapore and Brazil. It's a subtropical climate, which means that there's a heavy amount of sedimentation underwater, which is actually quite bad because corals only grow during the warm season, and the cold season they hibernate, and sedimentation can actually suffocate them. The same, there's a rich underwater biodiversity, and going back to coral growth patterns, they need to compete with other species, especially algae grow really fast and they can suffocate corals. And last, there's such a rich culture of diving in Hong Kong, and because basically we built around 150 tiles, and that was really good because we had a lot of volunteer divers for deployment. So, and this conducted how we wanted to design these tiles, and I'm going to explain that a little bit later. So initially we had this test right before I joined the project, this concrete test. And it was decided really early on that the habitats will be designed only for coral fragments. So a few coral fragments will be placed within a surface, ideally in 2-3 years time, the fragments will grow enough to become a self-supporting structure and they won't need artificial habitat anymore. And the easiest way to design was to create hexagonal tiles, because as I said, they would be deployed underwater by normal people. So they would need to be easily assembled, because also divers can't spend too much time underwater and they would need quick solutions. They can't think about joinery and design specifications. And there were 2 problems with these initial tests. They weren't porous enough, so there was sedimentation deposited on them, and the material would damage underwater conditions because it's concrete. So right when I joined the project, we decided to switch to clay. Because it's a natural material and it would naturally decompose in a few years without damaging in any way underwater conditions. And the last restriction we were working with is that the tiles have to be about 65 cm in diameter, because they will need to host between 6 to 8 coral fragments. And as I mentioned, in Hong Kong waters, there's a heavy amount of sedimentation because it's tropical climate. So the most important thing was to create a porous tiles. So we decided to create the tiles out of 2 parts. The lower layers acting for protection from sedimentation and protection from the bottom of the ocean, and the upper ones as coral mimicry patterns that would allow the coral fragments to grow within them. So there was a lot of calibration we had to do, because there were the requests from the marine biology side, then there was material behavior, and there was machine behavior. So we started first by testing the bottom layers. The first test was a square grid, but the problem was that basically the nozzle dragged too much material within the intersections. Then we tried with a triangular grid, but the printing lines were too long. It was cracking when it was drying. Then we tried a trihexagonal grid, but it was also cracking when it was drying. So then we experimented with a space filling curve, but the tiles became too dense and there was too much material use. Printing time was too long. I forgot to mention we were quite a small team printing, and we also couldn't postpone the very precise deadline that we had because, as I said, corals only grow in the warm season. So we only had a margin of error of a few weeks within the year in which we could deploy the tiles. So finally, we created the diagrids and we divided the hexagon into separate parts. And that gave us, first of all, shorter printing lines. And the tiles were symmetrical around the center. So that means that when they were drying symmetrically and we didn't have cracking anymore. And the other problem that we had to account for was I said, the competing species. Algae is the biggest problem. They grow the fastest as opposed to corals, which are one of the species that grow the slowest. So we had to design these coral mimicry layers really like a shield to protect the coral fragments. So we started with a space filling curve, but it was irregular. So that created problems when it was drying, it was cracking. Sharp edges also are not good because they would interfere with coral growth patterns. So you really had to accommodate for how the corals naturally grow. So then we tried a shorted path logic, but again, there were long lines uninterrupted. So they were cracking when they were drying. Then we decided a mix between a space filling curve logic and a shortest path. And it was drying okay, but it was using too much material. It was taking too long to print. It was taking too long to dry. So finally, we decided on, we experimented with the Gosper fractal curve, and that was actually growing from the layers underneath because we were printing first the grid layers, and then on top of it, we were printing the coral mimicry layers. So they had to dry cohesively together. And each fractal subdivision was coinciding with the sides or the diagonal of the layer underneath. And then the subdivision was relaxed because we couldn't have sharp edges. And being that we kind of had a curve that started to work with the layers underneath, the last step we did was that we subdivided the curve even more to have shorter printing lines to dry better. And we added the pockets for corals because all coral fragments had about 6 to 8 cm that they needed as little pockets to be deposited in. And this was a challenge because once again, when we created bigger openings, we would have incohesive drawing. So we made this folding pattern. So whenever there's a pocket, the line right next to it get more dense to counterbalance the scarcity. So we also included these special handles in the patterns, which would signal the location of the legs because we couldn't just put the tiles on the bottom of the water. We had to print legs for them as well and elevate them slightly because there's sediment on the bottom of the water and the ground is uneven. So, and all ridges and trenches were at least 2.5 cm wide so that the corals can grow within them. And between every 3 tiles, there's this special tile that hosts the autonomous reef monitoring system. It's a standardized global measuring tool for underwater life behavior. And this brings me to discuss about the overall system and kind of concludes. As I mentioned, we had to print legs for the tiles as well. The way that we did that is that we would print the grid layers, then we would print the coral layers. We would wait for them to dry for about 4 days, and then we would flip them and print the legs. And then we created assemblies with 3 tiles holding the coral fragments and 1 tile holding the arms. And there's no formal divagation, there's no mass customization because we need to be able to trace the results. If results between tiles would be different, we wouldn't know if it's because of the geometry or because of the environment. So in all 3 sites, all tile units are completely identical. As I mentioned, we had a team of diving volunteers to deploy the tiles. And from the observations so far, both flora and fauna are accepting and are benefiting from the tiles. And there's also species we didn't expect interacting with them. The coral fragments are growing, as you can see. And yeah, this is about it, about this project. And I'd like to very briefly introduce another one. If so far I discussed about pure research, I really want to talk about how teaching has influenced my research. So I started teaching the year 2 program in Hong Kong University about 3 years ago. And the program focused on housing with studies on vernacular Chinese architecture in the second semester. And I was teaching a studio on traditional Chinese wooden houses. And I became really, really interested in the topic. And then this led me to collaborate with John Lin, who's the previous coordinator of the program, on the Traditional House of the Future project. So I'll present it briefly because it's at the beginning stage, and we haven't really been able to print so far because of the quite bad situation with COVID in Hong Kong. So I haven't really been able to be in the lab. The project is located in Guizhou, mainland China, in the village of Nanlong. So that's south central China. And the aim of the project is to create a new urban attraction that could generate touristic potential, benefit the village financially. And we're going to dismantle the existing wooden structure, restore it and reassemble it, and intervene with a new robotically printed wall. So that project actually deals with a very, very classical architecture issue, the way that we imagine it, with that of the skeleton and the skin. And I started questioning this issue as a design generator in the spring of 2021, with students intervening with a new wall language in traditional Northern Chinese houses. And the methodology followed through the next year. I had the opportunity to become the coordinator of year 2. And the studio was a great opportunity to pair teaching and research. And we did a workshop where we built a version of a wooden brick house prototype at 1:3 scale. And we imagined a new type of bricks that were porous and they were reacting with light. And it also allowed students to use reference from my previous work with Terra Performa. So they were creating novel bricks and stacking languages. For example, the project on the right, the student investigated how inclined channels can allow on the inside of the house for winter sun to penetrate, but deflect summer sun rays. And that's a technique used in traditional Northern Indian temples. And in Traditional House of the Future, there's an extensive research into discovering kind of like this new language of design between old and new that can both highlight the existing structure, but create cohesiveness with the 3D printed clay walls. So we've tested one continuous wall or a series of 3 or 4 walls, each with their own behavior. And we kind of concluded on one continuous wall because we're going to use on-site robotic arms that can only have a certain reach. So therefore, we started to use machine ink language as a form generator. And given the potential of computational design tools and robotic fabrication, the continuous wall for the house has different types of behavior. The geometry of the wall extends beyond the house. It creates enclosed courtyards, which is a very common feature in traditional Chinese houses. And it has a semi-private entry. And the two structures communicate, yet they're very clearly defined. These are some studies that we're doing about the tectonic relationship on the insides. And I'd like to highlight here this issue of non-exploitative architecture. And this includes exploitation of people and excluding them from the process. And this is something that we really don't want. So therefore, our construction process relies almost entirely on local builders and local villagers, and it creates a participatory process of construction with the village. So local woodworkers will help us in developing new ways of erecting the wooden structures, because it's not possible to build the wooden frames separately as usual and then put them up. So because they will be mounted after we 3D print the walls. And villagers will also participate with us in sourcing and mixing of clay for 3D printing. And a lot of families have already left the village. It's kind of an abandoned village. So the traces of their own domesticity have remained behind, and they will be repurposed for the traditional houses of the future. And on this note, I just want to quickly introduce my latest research project, Impossible Bricks. It aims to investigate how food waste can be paired with robotic fabrication, because food waste is the largest source of waste in Hong Kong. And I'm currently working together with 2 colleagues, Hao Tian Zhang and Tianning Li, on a prototype in Cheung Chau Island in Hong Kong, and we'll use oyster shells structurally, and that's inspired by actually 600 years of tradition of using oyster walls in Cantonese architecture. And we already did some tests this winter combining bioplastics, digital fabrication and scanning techniques. And I'd like to invite you to follow our work and stay tuned for the coming prototype this summer. Thank you very much.
Wow. Like, I don't know, it was such a amazing presentation. And to be like, and just to insert a little personal introduction to myself, also even I'm working a little bit bioplastic and this, so I relate to you a lot. So I think we have to have a discussion later on. But I do have a lot of questions, and I think we'll take it up once we have a panel discussion. So moving ahead, thank you, Lydia. Moving ahead now, it's Alex, it's your turn. So let me introduce you once. So again, he was also my professor at IAC. He was my professor for OTF, and it is great to introduce him again for this panel. So just to give a big small brief, Alexander Edouard is an architect and researcher combining new technologies in an attempt to improve how we build and live in our cities. He has a specialization in robotic fabrication and large-scale additive manufacturing. He has been the lead director for the open thesis fabrication, which is now 3DPA, and as well as the masters in robotic and advanced construction at IAC. And together with all the IAC staff, students, and industrial partners, he's investigating how new advances in material, digital fabrication, and computational design could lead to a better construction ecosystem towards a more efficient, affordable, sustainable, and personalized built environment. So Alex, this is yours now.
Thank you very much for the introduction, and very nice to see all of you today, and also see the wonderful presentation that we have seen before. Congrats Erno and Lidia for the good work. Let me share my screen quickly. You see my screen very well?
Still loading.
Even if it's loading.
Now you can see it. Yeah.
Okay, cool. 20 minutes, very short. So many things to show. I will go quickly through a couple of projects and ideas coming from IAC, this crazy research center and educational center in Barcelona that I am deeply in love with. A place where we explore different scale of architectures and different disciplines by methodology of learning by doing. So really making it happen, this future that we hope will be better. No? We have a lot of research that combined with education. A lot of the work you will see is also related to this educational program, the 3DPA. But we also work for companies and have different activities related to promotions, no? Where we work at different scale, different, let's say, focus area. Today we'll speak really about 3D printing in particular, but we've been influenced a lot by our research on environment, urbanism, and architecture. In particular, you will see some of the work that we've been developing in the Master of Robotics and Advanced Constructions, as well as the postgraduate in 3D printing and architecture that have been great terrains to explore these topics and also for our students to grow. And I see that some of them are here today. I'm very happy to see you growing. What are all this technology doing? No, we have the chance to be in a boom where digital technology entering the constructions. For example, this project where we're capable to 3D print a bridge. One of the first one in Madrid that was in this case made of concrete together with Acciona, D-Shape, and UPC, where we had certainly a huge design freedom. We have possibilities of using robots to make new processes, new materials, but also big liberty in terms of design. Now, this wonderful project that now is close to 10 years, Material, was showing how we could maybe print totally in mid-air and make these crazy geometries. If we push the limit of what we can do with materials, how we can control the robot, and how we can integrate all this technology. This said, we had a question for the technology. When you think about it, we have loved this quote from Cedric Price of technology is the answer, but what was the question? And it happens that we have plenty of questions to resolve and to tackle in our society, and especially in architecture, that this teeny video here would introduce, if it works. See. I don't know if I shut the sound now. I have it out. Do you hear the sound?
Yes, but that's okay.
As you could see, we have a very good collaboration with our colleagues at WASP, where we try to see how we can scale up all this research and apply it at a very large scale and try to empower more communities to develop. But I wanted to use a bit this short time that we have to show some of this detail in the way we design and explore these wonderful fields that is in front of us of 3D printing with natural materials that are not so easy. The first one you've seen was printing in mid-air, some epoxy in this case. So it was playing with very expensive material and chemical ones. But when we work with natural material as Earth, we have actually millenaries of experience in constructing an architecture, a space, type of construction that need to respect the Earth to understand this material, but also understand its potential, design a type of architecture. And here with Edouard, we like to show this relation between this past, the history, and how the new tools that we have available as designers could help us to explore this future. When we look, for example, at one of the main topics in Earth architectures, we print mainly against gravity. We have to deal with these problems. In 3D printing, we always have this problem of overhang, for example. But how can we explore the way to support these structures? No? And Erno was showing us a very nice research where you could fire these supports. We're trying to see if we could also be inspired by the way arch was built, how we could integrate wood in the way we construct new geometries, something that we could place just temporarily and find ways to then remove it and release geometries that were specifically designed to collaborate with the wood. So here, many inspiration, as you can see, from the way it was structured and how we could integrate with the specificity of the clay. This is something where we feel will be crucial when we look at a different type of architecture that we'll be able to build in more dense cities, and how we could push the boundaries of Earth 3D printing, know how we could actually design such beautiful space. Similarly, if we try to not have any support, but works only with the arch itself, and try to understand how we could build unsupported arch over times, we have many learnings we can get from history, exploring how we could reproduce these geometries, but also understand them using computational design to maybe generate them, but also analyze them, and trying to use, in this case, our own geometrical tools to understand them, combined with some structural analysis such as Caramba. We've been exploring at a type of methodologies that you will see across most of the project. That is basically a scientific methodology of having a set of catalogs, a set of objects that we both in the digital realm, but as well in the physical realm, to let the material express and tell us actually what geometries are really possible and what could be done in these systems. No? So you see how they collapse and learn from it, and then how finally we find out the right geometries, the right balance of gravity and shapes to define these new spaces. You know, how we can have finally these nervers in the vaults to create such beautiful space as in the Gothic church, for example, in the past. Now, how we can reinterpret these geometries. Similarly, we've been exploring a lot the question of light. Studently, with 3D printing, we have the opportunity to make the Earth building perforated or like a bit more evanescent, letting light go through the building, but also let a certain level of transparency. Many projects have inspired us, but also discovered we have many tools available, or let's say scales of operation in which we can act, exploring different ways of let's say building and designing these geometries. Again, a set of catalog to understand what are the limits of Earth, what are the limits of these geometries that we could push, using, as you see, sometimes some simple analysis. For example, in this case, we consider really the inclination, or let's say the cantilever that we can achieve with the building, but also inertia of a small object like this one. And then when you multiply it at a very big scale and understand how we can play with it, you can construct a totally different systems. What is important here is that you evidently consider the structure, but you also consider the view as a vector, as how we go through the building and how the light can drive these openings, and how we could make that in such a point of view. There's no so much transparency, but from another angle, suddenly a view reveal, letting or choosing, let's say by design, how much light and how much view we could have behind our walls. This is the kind of thing that then we explore at a larger scale, at the scale of architecture, how we can distribute spaces according to this transparency, how we could be also inspired by the way communities have been building their village according to different level of privacy. And for example, this student that have explored a type of architectures where you would have nucleus a bit more intimate and different public space that are a bit more transparent. So how we can really move or translate this learning from the very small scale to the large scale. Similarly, we've been exploring many different performance. Another one that is very interesting is the question of the wind and the air flowing into the systems. I believe, like most of tried CFD analysis and different type of tool for these elements, but very difficult to physically simulate it in a proper way. And we start to have our own tools that allow us to make quick iterations. Here you can see the technique of the sand spread with pressured air. We also have some other experiments with smoke. Very interesting to learn and to understand how we could play with architectures and the detail of our structures to shape ventilation in the building. Similarly, we started to look at how we can play with the rain or with the water and how this can move on the surface of our building, either to eject it or remove it far from the building, something that is very important in earth architectures, or try to collect it in certain space when we need it more, and therefore concentrate certain area of our wall that we need more reinforcement to the water. The question of thermal transmittance as well, so how we can design and detail all the part of the building to handle different, let's say, question of insulation buildings. So even if we design, as you've seen in the first video, which was our walls to be excellently performative in being insulated, something that was not so easy in earth architecture. But now we're also looking at how we integrate with the frame, door, windows, what are the different details, and how we can use, again, the performance as a drivers for our design. We are starting to explore other aspects as well, for example, the ergonomy, how the body, the human body is affecting the way we design a space. For example, here study on integrating sink in a wall. So how we design the sink, how we make it repairable or integrated in the systems, and working really with the body, that we can both test simulations, but also scan people with simple technology like Kinect or different elements. All of these learnings and exploration, we are bringing it back into our prototype we built recently in Valdaura, that is a forest campus that we have available at 20 minutes from the Barcelona city centers, where the students of this year, 3DPA, have built this very nice prototype that integrated some of the learning in the windows, in the fibers, in different detail that could be key of releasing this architecture. For example, here, how we detail the wood structures to be embedded in the earth, and how we can have this dialogue between the earth as a massive wall and this lightweight structure that cover from the rain and the sun, but also need to be anchored to the ground and to not fly away. Most of the building of earth that you will see will tends to have the wood going down to the ground and not necessarily embedded with the earth. So how we make stick this different materiality is a very interesting research. The final prototype has integrated like this puzzle of details in a demonstrator that shows that it's possible to handle all this complexity in one project, and hopefully something we will be able to scale up quite easily thanks to this algorithm. A small video show this latest prototype yet to be published properly with the document. Sorry. We have to mention that this is one of the first projects that really use a local soil that we have available in Barcelona, working all the process of the earth, sifting it, preparing it, mixing it with natural fibers, and trying to build this prototype that is fully respectful of the site. The foundation itself is made of gabions, recycling stones. The roof is made of wood that could be extracted from the same forest. Everything could be built with material within not even a kilometer from the site if we wanted. These have been built in months and a half with the help of the 18 students of this year 3D program, and demonstrated that it was possible to have a new type of architecture. As you can see in this image, the intricacy of all the detail integrated in the wall, how all of these elements from the ventilation, the structure, the water details, how all these important details in architecture are negotiated into one piece is very key. And there's also these beautiful things of 3D printing that we have full control of this architecture. And hopefully we'll soon publish much more document and information about this, as well as the wonderful work of our students, all in detail. So I invite you to follow a bit our website and social media for more information very soon. Just before closing, I would like to say that we have this fantastic collaboration with Colette that offers scholarship for students to join us in this program, especially people that are with some needs economical support is from Africa, Asia, and South America, where we believe this type of architecture could have a huge impact. Thank you very much, and I'm looking forward for the follow-up discussion that we'll have later. And I would like to also thank all the amazing team, students, and collaborators that are behind this project. It's really needed to work together to make it happen. Thank you.
Thank you so much, Alex. It was really amazing. Like what it's culminated from when I was over there and to what is developed over here. It's like amazing, and like I think we're going ahead with that in a very faster way, and it's developing into a very amazing research. So I think everybody's looking forward to it. Now moving on to our final presenters. So just to introduce both of them. So first is Negar Kalantar. She is an associate professor of architecture and a co-director of Digital Craft Lab at California College of the Arts in San Francisco. Her research is additive manufacturing, robotic construction, transferable design, and advanced geometries and materials has been awarded by the National Science Foundation. By bringing together digital and analog fabrication workflows across scales, interdisciplinary research practice broadly investigates how to bridge the recent advancements in additive manufacturing technologies with large-scale structures. Also presenting with her is Dr. Mehdi Farahbakhsh. Sorry if I'm pronouncing her name a little bit wrong. He is an educator and researcher in the College of Architecture at the Center for Infrastructure Renewal at Texas A&M University. His study and practice integrate art, technology, philosophy, and human social interactions. Mehdi holds a PhD in architecture from Texas A&M University, focusing on the robotic-assisted additive manufacturing of scaffold-free shell structures, human-robot collaboration, and digital fabrication technologies. He practiced architecture for 8 years and designed more than 1 million square feet of architectural spaces. So the floor is all yours.
Thank you so much. Share my screen. Okay. Do you see my screen?
Yes.
Okay. Thank you for having us. And our today's topic of presentation is robotic clay printing, where the past meets the future. When we say clay and we think about that, clay 3D printing, we all think about the advancement of the technology, what is happening today. But earth architecture has really, a long history in the background. And we had a lot of techniques and development in the history that developed for this, specific material, from pouring, casting, cutting, and extrusion. And when we see, historical architecture from Middle Eastern, countries and around the world, Africa, we've seen amazing, masterpiece with this materials. The inside, seems, amazing, larger scale structures out of this materials. But when you look at from the outside, it's not just the, one standalone building, it's the whole cities out of this material. And, we have civilization, 1,000 years of, skills and knowledge related to the earth architecture. That when today we talk about, clay as a material for building construction, always think about that, how we can use all of those techniques and all of this amazing, historical, geometrical knowledge that human beings develop, and how we can use them in our current, practice. But something that is, I think is happening is the disconnected research and knowledge that, they don't, a lot of this research about the historical geometries and structure are connected to the other research domain. And it's not maybe our the main research that we are doing in a technology side, and so on how we can connect this domain of the research together. But starting for our talk today, thinking about that, what is the design for additive manufacturing with robotics, there is a huge difference between the conventional method of construction, that the fabrication and construction comes out of the after the design process, and the design is, and the communication between fabrication and design comes with coding and standards, because it's become, a routine for the fabrication. But when we are dealing with the new technologies, or I think the robotic or 3D printing, it should happen during the design process. So it's not a post process of the design. So it could be, it should be considered during the design process. If we really want to, have a real construction with 3D printing, I think we are dealing with these 4 domains of material, design and fabrication, hardware and software development, and the logistics and codings, and how we can deal with the new rules for the construction. In the hardware and software, today me and Mehdi gonna talk about few projects and research that we have done in this domain. And for the hardware and software, I want to share about the collaborative research with ETH and Texas A&M that we were proposing this workshop about that how we can deal with the material look like clay that has, is a, live materials, and during the process of fabrication, it changes its own property, and it's not the same as, FDM or printing with the plastic. So each layer has its own property. It can change during the process, the shrinkage, or a lot of things happen with the natural materials, and how we can control that one. The thing that we were proposing was how we can real-time sensing, and it was more about not X and Y, it was more about the Z axis. So we embedded, the laser on the top of the extruder and monitoring the previous layers and the substrate under the printing. But the whole idea was not dealing with the Z-axis or the knowing the topology of the substrate. So we were dealing with the 2D projection of the geometry that you want to print, and this, the sensing happens during the printing and knowing that what is the substrate geometry is under the print. So with that one, I think we could almost print on any surface, and the other part is if there is any error on the previous layers, we can compensate on the upper layer. And that was, presented in ETH for the digital future, for the workshop for the printing. Yes, robots. Thank you. And the next project was about, material exploration, that we had this grant from the president of Texas A&M on exploring the new materials for 3D printing. And today, when we talk about the materials in the position of being an architect and designer, we can deal with, I think, this three domain of, how we can design a new materials and how we can work with the geometry and with computational design, how we can change the property of the material. But in the middle is I think the real potential that through the fabrication, how we can tune the material behavior. And our grants was about that, how we can be inspired with the natural materials, and how animals, by adding a little biochemical to the clay and the existing soil materials, they make the structure. And it was a collaborative between material engineering, structural engineering, and us as a designer. And Mehdi?
Yeah, so when we were talking about earth architecture in the building scale, in the larger scale, we're dealing with three different scales. We categorize this in micro, meso, and macro scale, which micro is more related to the material properties and the ingredients, components of the material. But when we talk about the design part as architects, we were dealing with meso scale, which more about the 3D printing process parameters, and also the macro scale, which is more related to the geometry of the form. But it is not just a linear relation between those scales. It's much more complex relation between these scales that I will talk in a little bit about it. In first part, we were trying to replace or substitute concrete with some clay-based material that, if I want to call it clay-based material, and it was a collaboration with architects, construction scientists, chemists, civil engineers, and soil and crops science. And we had a collaboration with the Autodesk Technology Center in San Francisco. So we were dealing with two different aspects: climate change, that building industry is responsible for 38% of pollution, and concrete in particular is responsible for almost 8% of that. And also considering the technology and material breakthroughs that, for example, there's a prediction that future buildings will be made out of mud. So this is the definition of additive manufacturing in ASTM International. And this chart is a research by Erno, who presented his fascinating work earlier today. And with this chart, I want to emphasize how important it is that we know what other people have done in this field. We are standing on the shoulder of giants before us during the 1,000 years of kind of the history. And we will talk a little more about that we are trying, most of those people are not publishing, or maybe not publishing in English. And we're trying to see what we can do and creating an open source kind of feature for that. Negar will talk in more detail about it in a bit. So we have published one paper that how you can literally use your backyard soil to make a construction material and 3D print with that one. So in this aspect, we had some struggling challenges with the tool that we wanted. It is, I guess, a few years ago, so there was not any any kind of 3D extruder available on market that we can use. So we came up with a design of the extruder with the material that we wanted work with, that extruder that's working with the specific material. And these are just the iterations of the extruder. We were using something very simple, that just pneumatic system, and then a mechanical and pneumatic system, a combination of those. And we have published a paper on the impact of robotic 3D printing process parameters, which is the mezzo scale that I was talking about. And the importance of this scale is the binding between layers. And this is important when you're talking about, for example, lateral forces like earthquake or something like that. And the binding between layers is very challenging, and cold joints or other stuff. We have a workflow here that we focus on design, fabrication, digital reconstruction of those fabrication to analyze the data. So we hypothesize something, and that I will talk about it in a bit. And then we wanted to make sure what we are claiming is true based on the data. So we defined a few parameters that everybody is dealing with, and we systematically manipulate 3 of those parameters. And you see the effect of changing one parameter, how it changes the print result. But it is not just aesthetic; it is more than that. For example, in this demonstration, you can see changing just one parameter, which is H2, the distance between nozzle and the previous layer. On the left side, on the right side, you see the conventional layering, and on the left side, you see it is kind of replicating the compaction or the densification between layers. And okay, we were thinking maybe it is improving the binding between layers, and we wanted to prove that. So we came up with different patterns by changing those parameters that I already introduced. And we applied them into different scales. That mezzo results was applied into macro scale. And you can see here, we were using those samples with a MRI machine to make a digital model of a 3D printed physical model and bring that into the digital world again and analyze it. And you can see here on the right side, you can see when you put it in the finite element software analysis like COMSOL, for example, we are trying to see what's the reaction or what's the bond strength between the layers. And we created a library that with all those features, all those parameters, that can be used by a designer or AI algorithm in the future. If you want to design, for example, a geometry, you know what's the reaction or you can predict what's the behavior of the form. So to test that, we had the results in the digital world. We want to make sure those results are valid in the physical world. So we ran some physical tests as well. As you can see here on the right, it depends on the orientation of the force that you apply to the sample. We chose the C sample, the bottom one. And through a series of physical tests, ASTM tests, we found the flexural strengths of the specimens. And you can see on the left side, it's the conventional layering, and on the middle side, you can see the difference, how much difference it makes when you change the parameters and the bond strengths between layers. And it also affects the geometry of the layers. And here you can see the green chart shows you the improvement of the bond strengths between layers. And in the 95 samples that we kind of tested, we could improve 41% of the bond strengths between layers. So we have two approaches here in terms of material. I was talking so far about material, but in terms of design and fabrication, we have two approaches: print in print and print on print. It is kind of discrete approach to design that you can build structures larger than the scale of the robot, because almost all the printers, all the robots that we are using, they're dealing with the scale of the object that they can print. And what if we want to build something that is larger than the scale of the robot? So we were also following the precedent approaches of traditional construction, and we applied that into new technologies like this. And
yeah, thank you.
It is kind of,
we want to talk about, the design aspect of for the technology look like 3D printing, what's going to be the design approach on that one. And one of the design proposal that we have is a nesting fabrication. I'm going to talk about the three aspects of that, but it's more about that how we can use the smaller tools for the larger construction, and how we can use the whole area of under the tools for fabrication. And these are the three scale of nesting: 2D nesting, 2.5D nesting, and 3D nesting. And all of those has the similarity that how we can have less material wastage and how we can have more compact printing. And it's more about how we can break the overall geometry to the components that could be compact inside each other. And we use, the whole area that the tools can offer for us. So the slicing or designing the component scale comes from the limits of the tools. And this is a 3D nesting. I'll go through each of them. So for the 2D nesting is more popular, and it's more about that how we can in manufacturing, how we nest the components inside each other. But we are not talking about that one. We're talking about that how each module is suggesting what's going to be the surface of the next module. So all the modules can come from out of one stack of materials. In a 2.5D nesting, it's more about that how we can have a closed or open geometry, but the components of each module means that the inner surface of the first module is defining the outer layer of the second module. And we can have a closed geometry or open geometries. In a closed geometry, as I explained, all the modules come from one stack of materials. So it can be produced all as a one piece materials, and they come out of each other, and they can be stacked to the final form that we designed. In a 2.5D nesting, the stack of the materials, we have to break it when the curvature of the geometry is changing. So for example, for that geometry that has a different curvature, we have for the stack of material for production. And we had this proposal. I'm working with the California College of the Arts students with the same technique, how we can have the CT trees and having the structure that for the location that we cannot grow trees, and we can have this, clay structure that the plants could grow on top of these structures. For the open geometry, is more open to the design as well. So we can have more complex geometries. And again, it could be produced with the stack of materials that comes out of each other. And it's any closed geometry or any geometry could be cut and it's become more free in a design production. And the components and the, could be variable based on the fabrication process. So for example, that the dome structure could have very different type of the stack of materials. In a 3D nesting, we are dealing with more freedom in the structure. So it was more look like generating the language for the design and how from one stack of materials, we can produce any type of bending twist or a combination of all of those in the overall geometry. And when we know that one, we can return and go back and understand that how we can break the overall geometry to the components. But the main difference between 3D and 2D, 2.5D nesting is we're dealing with non-parallel plane for the division, so we can have angle or twist in the surface. But the idea is how we, for having a large scale printing, how we can have the components that are more, compact and could be, transported all together and assembled on the side. In the process of fabrication, for this geometry, we can deal with the subtractive or additive. In the subtractive, we can wire cut. And the reason is we can cut the formwork and short click on the surface of those, geometry. And in the subtractive, again, we have a stack of materials and we can bring all the components out of that. This is a case study that we did, to start designing the nesting, design fabrication. This was the first case study that we did in Autodesk Technology Center in Boston, that we did 2-volt structure out of the stack of materials with no, without any waste, and all the connections came out of the tools. And, it could be assembled from the meat of the structure and rise without having any crane or any, scaffolding. And we could ship it back to the, Texas A&M with 2, stack of materials with the FedEx. So it's more about that, how we can just, think about the whole process during the design process. But in the additive manufacturing or, print in print or print on print, mainly we are dealing with the extrusion of the surfaces. And because of the scaffolding, it's really hard to remove for the material look like clay or concrete, how we can not deal with just a straight surface. So we are talking about these 2 methods of print in print and print on print. Mehdi?
In demonstration of the print and print, we had a project at Texas A&M University. It was a student project mostly, and we were using the nested 3D printing strategy. So we used this small robot IRB 1200, which is I think the smallest ABB robot, and we were stacking or we were printing the geometry in different stacks. And there was a rule, as Negar explained for it. So in each geometry, you need to break it down into different heights with the same height, and that can be nested into each other. And the rule for that, the design rule for that is anywhere. So a geometry consists of positive, negative, or zero curvature, and whenever the curvature of a surface is changing, we need to break it down and put it in a different stack. So we can take it out either with moving, rotating, or a combination of moving and rotating. This is where we used clay as a form work in this kind of prototype. We printed clay as a form work, and then when we cast concrete between the layers. And when clay was dried, it could easily be broken with hand or let it soak in the water, and it would dissolve in the water, as you can see on the left. And the point was how we can, again, print a structure which is larger than the scale of the robot. And it is a discrete approach to the design. So we had a for this demonstration, we had a dry kind of installation system, and that we could put all the components on top of each other. And the point is, when you can stack them, as Negar explained, when you stack them, the transportation is very easy. And for example, this one, 2.8 meters of the structure could be stacked in SUV, in an SUV when you put them all together. And it was installed on the campus of Texas A&M University. And your imagination will be your limitation when you're dealing with this. So these are some examples of this, the geometries that it can be produced with this approach. And as you can see, the orientation and the way that you stack them can be very varied. And the print-on-print strategy, again, it can all be stacked on top of each other, and you can create a curvature form like this, for example, a porous form like this. Yeah, and this one, we were dealing with the design, material, and fabrication strategies to create that one. The only point is, most of the 3D printers, we are just dealing with the nozzle or the extruder is always facing down, or is perpendicular to the print surface. That way we cannot print inclined surfaces or non-vertical surfaces. On the left side, you see the result. But when you change the orientation of the nozzle or the deposition of the material, the print will be smoother, and you can print more free-form structures without additional support. For example, in this one, we're printing just a tiny bit of support for the first one, and we were stacking all of them on top of each other, and there was a barrier. It can be a powder you can spray on it. It can be a plastic shield between those two components. And as you can see on the left side, they were all stacked on top of each other. And then when you remove them and assemble them on a different way, you can get a result on the right side, which is more organic form or free form of architecture.
Yes, and so for example, for making the arch on the left side, you can have the stack of the material on the right side. So we can print the geometry that needs the scaffold without the scaffold and assemble them after that one. So these are some examples of generated with this idea of 3D nesting, and how all the geometry comes from the components that could be stackable, and the scaffold could come from the 2.5D nesting as well. So it could be a production or fabrication without any waste. We're using the same technique of 3D nesting for designing for the locations that we cannot have the advanced tool on the site, how we can take this the stack of the materials, for example, for pedestrian bridges, that we can take it to the site and assemble it there. This is a design proposal for, again, a remote areas that the robotic or advanced construction cannot happen on the site. And you can assemble all the components inside. So the technique could be used for different parts of the building, from the beam structure, cladding. But the idea is how, with the new technologies look like clay printing or robotic 3D printing, how we can have less waste of material, less machining time, less transportation, and storage, and less waste in overall. In conclusion, we think as a researcher that the gaps, how we can make the gaps smaller. There are a lot of people working parallelly on the topic of robotic printing, but a lot of things are overlapping, and we are not sharing the basic process and the challenges that we are dealing. So me and Mehdi have been working on a platform of how we can have a platform that all the researchers on this topic of additive manufacturing with the clay could contribute or add their research or resources on one platform so we can be more connected together. I'll share the link on the YouTube or the so we can if you are working on this topic, you can add your name or add your research on this platform, and our hope is we can work more closely together. And I think what Digital Future is doing every week is amazing because of making this gap much smaller and connect the researchers that are not in one countries or in one language or more connected together. And thank you. And this is our last slide. Thanks for the opportunity to share our work.
That was such an informative presentation, and I really enjoyed how you actually showed us the step-by-step observation of how the whole process can be executed in the different scales. And already we have so many questions being posted on our chat, so I will just start with one question, and I think let's put it to Erno first. This question is from Radu Fulga Studio. He asks, this is for all our presenters, but maybe Erno can go first. Should we expect a liberalization of architecture and construction facilitated by the evolving technology, that is the software and hardware, that becomes more and more available to anyone with a creative mind?
If I may, I was
Yeah.
talking to Ron Royal, who is kind of a pioneer in this field as well. And Alex also here mentioned this, also Erno mentioned this. This is more about empowering a community, empowering all people who are working in this field. It's not just about one project. Yes, the competition is always good. We all have competition in some sort, but it's more about the collaboration that kind of pushes the boundaries.
Anybody else who wants to make a comment on it?
I don't hear you well, Ritsi, that you were saying who?
Anybody else want to comment on this?
But I would just comment that I agree with Mehdi that there is let's say an empowerment happening of many designers around us, but that slowly we're also trying to empower people that are not necessarily like initial designer at a very high level as we are doing now, and how to make these tools more accessible, and that they became let's say tools to share knowledge. So that we embed this knowledge in algorithm, in project, in machines, so that people can take from that and construct a bit in the open source philosophy. You need to spend a bit of time to research, to develop, but also a lot of time documenting and putting all of this together. So I feel this is also very nice to create a community around those tools, and we all learn from it. So that's super interesting.
So, continuing with you, someone has a question for you. His name is Vishnu Hardinsia. Impressive project by the 3D students. Congratulations. I'm interested in the usage of pure earth material mix, which usually comes in complex properties due to its natural heterogeneity. How did you deal with such material complexity in order to achieve predictable overall strength and behavior?
Big topic. If you want, I'm writing a PhD on this. That will be very long, but to make it short, craft people have adapted the mix, adapted the technique, adapted even the time at which they were making wool according to the material, but also to the climate. Earth doesn't dry the same way under the sun or in a cold weather or something that is very dry. For example, they will never make finish a day that is dry and sunny, because you know that it will crack like crazy. So this kind of knowledge, when we look at robots and technology and digital tools, they seem a bit forgotten. We are a bit more brutal, let's say, with the matter, in the sense that there's a pump, a machine, and just push for it. And what we're doing is slowly trying to integrate sensors, analysis, cameras. We use thermal cameras that, for example, are very good to measure the temperature of the earth that release water by drying. So we can know in which state it is by checking its temperature, so how much water it releases. But we also try to detect the water content, the moisture content, try to relate all of this. So far, we don't have already yet developed the right algorithm in machine learning that is capable to deal with this data and tune the machine in live. But we're working on this, and maybe we'll have already some key elements. The way we deal with it today is to still have this craftsman on site adapting the machine and the design to the reality. So the building that you see that we printed with the student, for example, is not the one we designed at the first day we started. We adapted many details on the way, many small changes, because we've seen how the material behave. The mix have changed across the building. Many details have been tuned. So this is also what is beautiful in the building site. You have to adapt to the reality. And this is why we believe designers have to get a bit closer to the material and to the machine so that we tune all of this and make it much more collaborative, and they work together as craft we're doing before. They was understanding the material, understand the design, understanding the tools, and become a master in this synchrony between them. But yes, a long discussion on this topic. A very interesting one.
That's true. So another question is from Alvaro Fernandez, and it's for everyone on the floor. Beautiful results by the use of 3D printed clay in different scales. In that sense, I want to ask the presenters how to deal with dynamic forces like earthquakes using this material.
Earthquake, I think, is one of the main, problem of the clay, and for the, all the civilization, a lot of cities, gone because of the earthquake. But I think that having the new technology and hybrid, thinking about that, how we can enhance the property of the material, that is the weakness of that, through, having the hybrid system of the structure could be another one approach. For example, with Mehdi explaining about that binding, how we can increase the binding of the layers, is one of the researches that I think a lot of institutions are working on that one. And I think something that is unique about our era is changing the property of each layer of the material. And I think the structure has different property in different sections. But before, in the process of traditional construction, we didn't have that much control during the fabrication or construction. Now we have that one, every layer, every point of the structure could have, specification on thickness and dimension, and even, tuning the chemical aspect of the material. So I think those are the advantages that now we have. But I think we can go for the hybrid structure. So it shouldn't be one, materials only exploration. So we can, mix and match materials for getting the better properties.
That's true.
If I can add, I think also what's interesting about clay printing is that basically what it did, it gave a new life to a material that we weren't really using anymore in the contemporary design language. But I think something that we should be kind of cautious about is over designing or over, let's say, optimizing, even though we have the tools to do that. But if we look at the history of architecture, clay architecture in Iran wasn't the same as it was in Turkey. And I think it's just, let's say, common sense when you deal with architecture that you relate the scale, you relate the geometrical particularities with the site that you're dealing with. So I think creating site-tailored conditions in architecture that is and designs that are relevant in the site that they're in is also one way to account for that. If you're working, for example, in an area which is a high earthquake area, of course you would have to design in a very different way that you would design in a place like Hong Kong, where there's no earthquakes, but there's typhoon and other limitations. So I think it's all about the site that you're mediating.
Yeah. And I can add something. For example, Nader Khalili had this institution in California named CalAir. And his suggestion for working with the clay was if you bake the whole piece of the building as a one piece, it becomes one standalone, structure. And detaching the structure from the base, if the earthquake happen, the piece, become a standalone moving object. So I think those type of, approaches are very innovative. That's how we can think about the, not the weakness, but the real property of material, and think about that what processes could, advance those property. And I think here's one of the good example of working with a material that nobody believes that, okay, it can be, I don't know, new, contemporary material for architecture, and we can look at his example of the building.
Yeah.
Very interesting. Actually, I don't know if it was in your region, etc., but I know that in India they have some experience in firing the entire dome. Ramakondo had made a test on this as well, to repeat it. For us, we tried as well. We had many issues with this. First, because clay retract already by default. We succeed to fine tune all the material to retract it only to 1%, but normally it's more like 5-6%. With the firing, you get an extra 6%. So when you have the entire shape trying to move this amount, it's very difficult to have not too much cracks. It's not so easy.
Mm-hmm.
And it consumes a lot of energy and it's not very sustainable. So we are moving slowly away from this because at this point it is better. We're like, okay, no, because it's also fired, but in a controlled environment, let's say, so that would be easier. Or the technique you're doing, that I think is fantastic, of more like prefabrication, installing on site. So I feel we have to find solution for the on-site version of 3D printing with Earth, with different technique. One of them we're exploring is working with the fibers, embedding them in different possibilities. We had a couple of research on this topic I didn't show now because they're not yet ready, but we see there's potential is to embed the fiber in the material by depositing it at the same time as the 3D printing, or probably more potential is the post tensioning as you are doing with your bridge. We see this as a very big potential because you can decide the direction of the fibers much more easily and apply this tension even if the material retract or move a bit. There's also a lot of learning from earth codes in Mexico, Peru, and earthquake places where they had many earth building and try to find solutions for earthquake-related building issue. Sorry. And there's very interesting solution that I didn't think was existing before. For example, to wrap the entire building with a fabric and tighten it from inside and outside, and therefore you obtain the reaction you're mentioning of getting the object moving together. And I'm sure we can be very creative about this, and there's a good 10 years of research in front of us to look at this. Also appreciate a lot your weaving technique in the clay that clearly would have a positive impact on these lateral forces. So many things to look at and to push forward.
But I had one question, like it's a very basic question. It's about the affordability of this technology and like when we're deploying it in these different sites and different contexts. So how are we looking at executing the machine, and we know the material is local material, but the machine that will be deployed on site, how do we look at it in terms of affordability for construction?
Clay and Adobe may be very different in this aspect because clay more prefabrication, more firing before, and it's a whole industry that exists. That the advantage that on factory could be very industrialized. I think Erno was mentioning this idea of like, okay, how can I scale up? We have similar issue. I didn't show we have a project also on ceramics. We work with Tony Kumeya that have his own factory and produce a lot of ceramics, very good quality. And so he pointed out we are very slow with our 3D printing, but he has a chain of production behind that is very good. On the Earth world, we know so a lot of association, and sorry, just to finish on the ceramics, from what we hear, and for the at least they struggle to still be competitive with the concrete that is damn cheap, and it's difficult to also still introduce a part of design and element inside without being just on the mass production scale. That is difficult, but he succeeded so far to do it. Let's see if the gas price will not, unfortunately, destroy this last craft. But on the Earth side, we know there's many, before being 3D printed, like the Earth as a construction technique is not cheaper than concrete today, even if the material is extracted directly from the soil, because it needs a lot of knowledge and people to actually produce it. The machine we have are not cheap for now, so probably will not be cheaper than Earth, that is not cheaper than concrete. This said, I still believe in the talent of architect, designers, and people to reduce this cost by design, by being efficient on the material, efficient on the way we develop these things, and have a significant impact on the way we are clever. We've seen like beautiful projects today that demonstrate that if you're really clever in the way you put them together in design, you can save a lot of material, a lot of printing time. We are aware of this, we're in control of this, and we can deliver, therefore, I think, affordable housing in this context. And then evidently there's a hope of scale. No, now this robot expensive, but maybe in 10 years from now, it will be cheap. Who knows? Probably.
So I like to add, that's a very good, very interesting point, Alex, you're mentioning. I think we really need more research in terms of material that we want to use. For example, when you're talking about adding fibers, in the past, they were adding straw, but it was not when they added a straw to the clay, they could use it right away. They needed to wait 14 days. And when it was smelling so bad, the color was different. And that was the moment they could use it in kind of structures. But now we're a little impatient in terms of time, or we are limited in terms of time. And also we don't have enough deep research in terms of bio-based material that we can use. For example, I was talking to someone in UK, and they were suggesting adding kind of bacteria that accelerates the process of drying, or not curing, just the drying of the clay, that accelerates the whole process. So again, I think one of the projects, Alex, you showed about the printing in the air, kind of the material that you came up with. I think I talked with Sasha, your colleague, at that time, and Sasha was talking about the reason that we couldn't go further. It was just material knowledge. We need more people from other disciplines, for example, from chemistry or some other disciplines, to help us improve this part that we don't have expertise in.
And they are doing amazing job in the material science, but we need to plug them in the right place, in the right challenges. The only issue that we have with Earth, I don't know, maybe with other projects there's advantage, but there is no business in selling material. And so there's not so much incentive to be creating a whole research and a whole line if it's not at the public scale or with public funding. Because once we know the recipe, we'll do it locally. The only advantage maybe is that we will need consultants for each and single site, because no one Earth is similar. So we will need always to have someone that is expert telling us a bit how to do that. But it's difficult to find this field. If you're interested on this topic, on Earth-based systems, the best research in terms of material is developed by Crater in French, Grenoble. They are the UNESCO chair of Earth construction, and the main investigation is on preserving Earth buildings that cover now 1/3 of the population and of the planet. And they have amazing resources. I think they have more than 150 receipts just for coating the facade outside, from all type of things, from the cow sheets all the way to the most advanced systems. But for sure, we can do more. And I'm joining you as a call for it. We want to see more, especially now that we understand better what's happening in the level of biology and integration of this raw material.
Before moving to the next topic, when you talk about affordability, I think it's about the context. And when we think about, for example, for nature, the most expensive thing is material because they have to make it by themselves. For us, because we are all the user of the material, expense is different. We think that, okay, tools is expensive. But I think that it depends, when we are talking about the skill set. And traditionally, people that could make this dome structure, or they were really rare people that they could do this type of, structure. So making this knowledge available means that we train the robot. We take the machine that can do this, the job that one person could do now in more location. I think that's more about, making a knowledge more available to more people. And the other thing is, for example, taking a material from Earth to the Mars or other planets. It doesn't make sense. So it's more about, the context and available, affordability doesn't mean, I think, just the final cost that now we are paying. In overall, I think we are very close to the research side of this, technology. So it's more expensive. After, it become more available, I think the cost and become much less and it become more affordable for everybody.
Yeah, so I think Neil is also here, has joined with us. So he has a question for all of you. Neil, are you here?
Yes, thanks, Ipsita. Thank you for these great presentations today. Really very, very strong work. I was kind of reminded, especially with Negar's and Mehdi's work, of my background work with Baruch Schnevis. It's almost like your Baruch 2.0. Afari, very good. I want to maybe make a slight provocation in some ways. I think what I find interesting about this work, and I guess the extreme version would be kind of Akim Menges, who's really pushing fabrication to a limit and producing these things. In a sense, that the irony or the paradox is that we're architects and we don't actually build things and don't normally do this. And it just struck me when I was thinking about the kind of stackability of the work that Mehdi and Negar were doing was kind of suggesting something further. In other words, when I think about the failure of the Bauhaus, to my mind, the Bauhaus is going to be very cheap for the everyday person, and it really didn't take off. But someone like IKEA has, And why does IKEA take off? Because the flat packing and all these things. There's a whole sort of logic of you can put together, assemble these things with instructions that don't have any words on it. They're all diagrams, and it's very clever at many different levels. And I'm just thinking that really, in order to make this work really, which is very provocative work, but really to make it kind of in some ways, I wouldn't say relevant, but really to have it have full impact, there has to be some research also into rethinking the systems by which we operate. And I'm thinking in particular of the way that Philippe Yuan has got a system going. He doesn't work with clay; he works with 3D printing other materials. But as an architect and also a constructor, he kind of integrates the whole system and has a factory in Shanghai where he puts together these things and they're then taken to site and built. And it seems to me that really what we're missing is really to try and find, and you have to use the architectural imagination to rethink not just the fabrication processes, and of course that's very important, but also to rethink the whole delivery of buildings and how the role of the architect might just, we could maybe kind of rethink what the architect is, because at one level the architect's been completely marginalized, absolutely marginalized. I was the translator of Alberti, and he of course defined this architect as somebody being in charge of everything and so on, and the work person or the laborer was only a tool in the hand of the architect. But now we found a situation whereby the architects in certain countries, and in the UK for example, they're marginalized. Most architects are now working for developers. So instead of the work person being a tool in the hand of the architect's a tool in the hand of the developer. And in order to really make this work really resonate and have implications, I think we've got to try and also put some thinking into how we might rethink the whole logic of deliverables. And I know that Ron Real, in his own small way, is doing that with local communities. But it seems to me that that's the kind of the big challenge as to how to rethink the whole structure of the construction industry, whereby we can use that architectural imagination in new ways to rethink not just the structural logics or the constructional logics, but also the kind of logics of deliverables. I just want to throw that out there as a kind of thought for you guys. I know it's not your expertise, but it somehow seems to be implied by some of the things that you're suggesting. Yeah.
Neil, thank you so much for bringing up about the system. And I saw that there was a question about working with other field engineers and other, discipline. I worked for maybe 10 years more in a collaborative settings of the research and working with engineers. One thing that I learned was how we can generalize things and make a system out of the process. And when I compare that with our profession, I feel that we do a lot of things from scratch every time, and that make it inefficient. And that's the way, and I know that that's the property of the design thinking novel, but how we can think about a design process, or how we can think about more than one project and thinking about a system. And I think robotic and printing, because it's novel, it gives the chance for architects or designers to practice this and think about that, how we can design a system for this new technology. Maybe going back and thinking about, I don't know, other techniques that is very, rooted in the profession, it's harder to change them. But at least in this new, era or this new research topic, we have this chance. And I think you were moderating the, the bridge 3D printing bridge session, and ETH team talked about that. Okay, now we have this technology. This is more the lack of design. This is more the lack of thinking about how we can design for this. The wellness of technology will go away. But, I think that the basic thing that's going to stay with us is the, the system thinking that we can have with this new technology.
So I think
I completely agree with that. I mean, I think in some ways, almost that's all we are is systems thinkers, actually, in architecture. I mean, I always think about this famous kind of question that Steve Wozniak put to Steve Jobs, like, what do you do? You don't code, you don't, what do you? And he said, well, I'm the conductor, and I think that architects are the conductors in many ways. We're not specialists in anything, but we have an overview, and we can draw upon expertise from other sort of people. And I just think that actually, to my mind, I think we need to rethink the logic of what is an architect to being a systems thinker in some senses, or at least potentially being that. And it struck me that that's exactly, we could also use that in imagination to think how systems operate, and I'm struck by the fact that that TED Talks were actually invented by an architect, and and to my mind, Digital Futures as a project is an architectural project, thinking about how you can reorder things, how you can find a system that is working more efficiently to disseminate knowledge and so on. So I just think that I know it's not trendy to think about kind of contractual issues and things, and we all like working with 3D printing and all that kind of stuff, and it's great and the forms are amazing. But in some ways, to make this relevant, we have to be really rigorous system thinkers and to, if not to become contractors, of course, but at least to be establishing a model that might have an impact on the world. And to my mind, that's the model, that's the challenge. How do you move from the Bauhaus to IKEA in terms of these things, so everybody knows how to put together these things and to assemble them in an easy way, because it has to be accessible in some senses.
Neil, if I can add something to your question, I think that's really true. And I think what we need to do right now as architects, if we want to participate in some way active to what's happening to this planet, is to really act as policymakers, as advocates for something. And I think it's interesting if you look just maybe in the last 10 years, since we started really using computational design tools in an implemented way and digital fabrication, we switched from being something that really belonged to the elites, like the works from 10, 15 years ago were very elitist, were very abstract, were really not dealing with, they were dealing more with an imagination, kind of a fetishized imagination of the future. But right now, kind of what happened is the reverse of it. We went to the extreme opposite. Most people dealing with 3D printing, with clay and architecture, with biomaterials are going to, let's say, more disadvantaged communities, rural communities, areas of the world which are not, let's say, the ones that are really producing money. So I think it's interesting to see that how something that was outside of the hands of the people, robots, coding, actually became something of the people. And I think we should take ownership of that and start changing there, and so instead of working top down as usual. And really, I think most of us are also educators. How do we teach design now? Do we still teach it the same, and then robots and all this is extra skills? Or do we really teach in a sense that we create designers from the beginning that are going to be the advocates of the future that we really need right now?
Yeah, just to follow that up, I think there's this distinction that sorry, Manuel de Landa makes between what he calls urban planning and urban designing. You know, and urban planning is where all the real decisions are made. You know, there's kind of the policy makers, the politicians and things, and the only designers, if you could call them designers, are kind of the infrastructure people, the engineers who design the roads. And then the urban designers as such are kind of putting the icing on the cake, you know, and we're so late in the whole process that all we do is just kind of, you know, polish things up. And I do think that we need to kind of think about how do you integrate them into the whole policy making decision to really make this sort of relevant. But anyway, it's just a provocation there to, I mean, it's fantastic work I've seen, but I think that it'd be interesting to maybe have a session with Philip Yarn at some point to see how he is trying to get from the kind of the design to making things in his own factory and getting them onto sites so that it's more kind of integrated as a process. Anyway, thank you.
Maybe if I can just jump on quickly. I think we have an interest in the technology as well for this control, certainly, of all this chain, where we can also, till the last minute, change things or connect them or speak to them. So that at least that's the experience we have in all the prototype and all the building we've been participating in. We're still tuning our algorithm, our machine, our fabrication process, all the way to what we see on the site, what we are doing. And we feel more empowered thanks to this technology to actually be in control of the chain. We start to have an expertise and let's say an aura that our collaborators, our industry partners, our clients trust our choice, understand that with our actions, we can actually reduce costs, we can make it more effective, we can achieve a certain performance that was not possible if we are just in a narrow space, no, but because we have this connection with the entire building process. And that's what's interesting. Also, another thing is that many companies start to see that the old ways of building or the old way of dealing with construction works in a certain manner, but will have limits. And we have more and more changes due to this economic / ecologic pressure that is happening on the construction sector. That makes that we will have to rethink those systems. And few people have this overview. Few people are capable to understand that you can change the design, you can change materials, you can change the process, you can change the way you assemble things together. And this holistic view is not something that is taught in many different disciplines. And I'm quite proud that architects are actually becoming also people that can question this construction industry. And we should be proud that we have something to bring on the market, and maybe go a bit away from this image of the artists that make the icing on the cake, as you mentioned, and allow to hide this huge building that we're building in the middle of the city for economic pressure, or to make the, I don't know, the art piece. I think we can contribute in much more aspect because we have this expertise. No, we don't question a doctor. We understand it's important to have this expertise, even if his knowledge is open, accessible. We can speak about it. We can have this communication. I think we have a good way to contribute in this change and this world. So I don't know. I'm very optimistic about effectively being system designers and integrate this, and hopefully this technology will allow us to embed this knowledge, this complexity in a set of tools that we use now with our students, but hopefully we'll be able to share among all the architects among us, learn to construct on top of each other. That is very difficult, it's true. We like to reinvent the wheel. But I don't know. I'm still hoping that this is going in the right direction. And at least here at EAC, we have a couple of utopists that also push for this direction and make it demonstrate that it's possible in certain cases. Looking forward to see more.
No, I think IAC is a good example of kind of breaking, challenging conventions, in education conventions and so on. I just want to say just the final thing is that I first came across Berachos Neves actually through IAC. It was giving a lecture back in 2000, God knows what, 6 or something like that. And he now has a factory as well. I am not in touch with him these days, but I should do. But there's a whole contour crafting factory somewhere in LA where he's working on these things. So yeah, absolutely.
Just emphasizing on what all you said, I think as architects, we have the big picture of the direction where we are heading. We're not designing the object, not even the building. We're designing the objective, or we are thinking about the objective of why we are doing it. And being consistent in what we are doing, like I think one of the key aspects or one of the main points in IAC being successful in this term is being continuous of transferring that knowledge through different generations of the students. So they're using, for example, this experimental research through different years. And that doesn't happen if we don't have an open source kind of resource for that. What exactly DigitalFUTURES is doing, connecting all the dots from all around the world, I think where Lidia is, Sun has said already, but here in where Negar is living, it's still up in the air. But the point is, I mean, there was a saying for Great Britain. They were saying in their empire, sun never sets. It is exactly what's happening in DigitalFUTURES empire.
I would just, I shouldn't tell the conversation, but I do think that the only reason why IAC exists in some ways is the failure of education to address certain things. It's kind of stepping in and saying, we need to do this. And, at some point, one would hope kind of actually that IAC would cancel itself out, that everybody realized, yes, we should be doing that. And there's no need for those institutions. But I mean, obviously they will be. But in some ways, that's exactly what DigitalFUTURES is doing. It's kind of like Philippe Morel came up with this analogy and saying, well, it's kind of doing to education what Uber did to taxis. It's pointing out, you guys are not doing very well. This is how you could be doing it. And I think the taxi services have kind of learned from Uber. So in some senses, I think there's always a kind of a need to continually kind of agitate and probe and try to improve, because otherwise you get this kind of complacency. And I think that right now, I mean, I think that the architecture profession is in a real crisis at the moment. I mean, I'm about to write a book called The Death of the Architect, which is kind of saying, well, it's AI is going to really make things even more difficult. But the point is, it's already struggling. No, it's already struggling. We only produce 5% of the buildings. Only 5% of the buildings ever done are designed by architects. And we are really becoming marginalized. So I think now is the time to really try and rethink the whole logic and use this architecture, because architects are super talented, to really think through the whole structure of things. And I think in some ways that it needs to go much deeper, but it's great to see young, smart, super smart people like yourselves taking up the challenge in terms of fabrication. And let's try and take it even further.
So yeah, I think before we are running out of time, but there are 2 more questions left and it's focused on Lidia. So one question Lakinya wants to ask is, if the coral reef designed and deployed for baked, wait 1 second. I would like to ask Lidia if the coral reefs designed and deployed for baked in kiln, and how long did the whole process take? She wants to essentially know how long the whole process take from building.
I saw this question and I was excited to answer it because I realized I forgot this part in my presentation. So It's actually a very, very lengthy process for each tile. So as I mentioned in the presentation, we would print the two type of layers first, then we would let it dry naturally for 4 days, then flip it over and 3D print the legs on it. And the problem is, even though we had a really big kiln, there was no way to move the tile with our hands from wherever we placed it into the kiln. So we actually ordered these pizza ceramic tiles that they use in pizza shops for the kilns. And that was the only way that we could put the tiles in the kiln and fire them. It was a 24-hour process, firing process. 12 hours for the kiln to get to maximum temperature, and then 12 hours for it to get down. But yeah, actually firing influenced a lot the way that we had to design them and the way that we had to think about really, let's say, hands-on solutions. And this is something that I really like working with clay, working with biomaterials, is that the material does so much in itself that no matter how much you try to digitalize and quantify the process, there's always going to be the human component in it. So that's why I'm really not afraid about the future of architects, because I think we will always be needed in one way or another, even for the mundane things. Maybe we become from the elitist ones, actually the laborers, but still I think there's still a need for us.
So any last thoughts from anyone? Like, no, would you like to give us your last thoughts?
Yeah, well, yeah, I could add, because I like the discussion before about the affordability. And there was also a question in the chat I saw about collaboration with the industry. And I think they have to do with each other very much, because adding clay printing doesn't add too much to the conventional process of making ceramics, except that, like Alexander said, we're very slow at the moment making these 3D prints. But it's a technical problem, maybe, because you can imagine all kind of ways to solve this problem. However, I think the industry needs incentive to work on this, and I think that's where maybe designers or architects could play a role, you know, to come up with reasons or designs or something to accelerate this innovation. And I think that's where the collaboration could be very successful and needed.
That's true. Alex, last thoughts?
Me?
Yes, any last thoughts?
World is full of challenge, but we have many things, many opportunity to make it happen. I don't know, something generic. I don't know what to say. I'm very excited to see actually that there's a momentum about all this clay printing and earth printing that we've seen today. There was also recently some more trends around these topics. It's very nice to see this this growth going on and all these different approach. So I'm very happy with this this community being built slowly, and let's see how we can exchange a bit more on those topics and make it grow.
Yeah, Lydia.
Maybe just on this topic of collaboration, one thing that I would say, because I saw there was already a question from Gustavo about how we can do that, in what country, how do we create funding. Maybe one thing is to don't underestimate whatever government you're under, because actually states do have the interest to better. I mean, yeah, I think I would never underestimate also the top management. I would always try to go all the way to the top, because you might find people willing to help or participate, or at least be curious. For example, the project that I showed in China, the 3D printed house is a local initiative from a village county head. So I think you should always try, even in the places you don't imagine you're going to get a positive response, because you might get it. It's just important to ask the question.
Yeah, that's true. Negar, Mehdi, what about you?
So in general, I want to say that it's a really exciting moment to be a designer. That I think that an architect, that how our names say that we are master of builder, and Neil said that we don't make anything, we just design things. But I think that having this new technologies that are hands-on experience, change the way that we can make things, and we can, bring our idea to reality, is a new way of practicing that is, I think, very unique for this being architect in this era. And that's very exciting, and I'm feeling that a lot of challenges that the world is around us are experiencing could be dealt with through the lens of the design. So it's a very unique time of living, a lot of challenges and a lot of opportunities. And I encourage all the students, and not just master or PhD level. I feel that a lot of talents, a lot of things can happen in early on education and in the undergraduate education. That's how we can restructure the system of teaching in the studios, and the thinking that how we can bring this novelty of the thinking and new ideas in the education of early on, and having a better designer for the future.
Thank you so much. I don't have anything to add, and I'm just enjoying the work all you're doing. And Erno, I'm happy that I hear you're planning to come back to the clay printing or ceramic printing.
So just to wrap up, thank you for your patience for this long panel discussion. I think all the presentations were wonderful, and we did get a lot of questions from you all, from the presentations that we saw, and we really need to think about it and go back and see how we can look at clay printing in architecture. Thank you all. Thank you, Negar. Thank you, Mehdi. Thank you, Erno, Lydia, and Alex. Before we wrap up, I just like to remind all our viewers about the sessions that would be held next, about the regional talk in Arabic, which is happening now in some time, about the doctoral consortium with Andy Clark, and about the tutorial session on 2nd April. Please do register for that. And yeah, thank you all for joining in, all the viewers on YouTube and all our presenters. It was wonderful to have this discussion and just broaden our minds for sure. Thank you so much.
Thank you, Ipsita. This I think, was your first session that you chaired. Congratulations, and thank you also to the team behind it, to Pavline, Gustavo, and so on and so on and so on. Thank you so much. Well done. Well done.
Goodbye.
Okay, bye-bye. Have a good day. Bye.
Thank you.